All right, folks, can you hear me clearly? Yeah. Those of you who are remote. So
yes, sir.
Wonderful. So welcome back to our 10th week of the LLM Bootcamp. I hope you're having fun. You may be a bit tired working on the projects, but I hope you're also having fun. Once again, it's a beautiful California morning here, Saturday, the 11th. It is also based on where you are, Diwali. So I wish you all a very happy Diwali. Today, the topic is Document AI. Document AI is a really big topic. It merits a little workshop of its own. And we have to compact it within a week. And today, we'll compact the paper readings and the core topics to just a few hours. So we have a lot of territory to cover. Now, the way to look at it is, if you look at it in the context of your project, in the project, you have a text that you are indexing for your search. You're doing RAG, you're doing question answers, you're doing essay generation from your text. You're also doing it for images, image comprehension, visual language understanding, video understanding, depth image understanding. Then the next stage that we went to was the generative aspect, in which we said you have to generate a complete essay out of the search responses, the RAG, but it must be understandable by an eighth grader, by a young person. And you also had to generate images using a diffusion model. We took a digression. We understood about adversarial attacks on these systems that can be made. And how do you defend against those adversarial attacks? The situation is it's far easier to attack than to defend. There are no very clear proven ways to defend at this moment. Then we went into audio. The last week, we gave a lot to the audio generation aspects of it. So on the audio generation, if you have reached this far, I thought I'll give you guys a bit of news. One of the things I gave that this project ultimately should have, one of the projects is, you should create a virtual teaching assistant. Right? How many of you made progress or have succeeded in doing that or come anywhere near or made any progress on that? No? So as I was, then I shouldn't release the solution, but I'll give you one hint. I took all the videos at Support Vector, so you may not be able to so easily download it because you'll have to scrape the web. There are ways to do it, but you'll have to scrape the web. So I'm going to give you the video IDs of all the videos, YouTube videos. There are about 350 of them, videos. They cover the entire range of topics from data wrangling, data visualization, machine learning, right? The tabular machine learning, the deep learning and everything, transformers. So I took a few of the videos and I saw when I passed it through Whisper, the output is pretty good. I thought it would make a lot of mistakes with my accent, but it did an amazing job. V3, the latest V3. It's just amazing. And one more thing that I found, I didn't know that, I sort of knew that I talk a lot, but it becomes embarrassingly obvious when I look at the transcript, because it turns out to have no less than 35,000 tokens in one video. 35,000 words per video. So that's a whole lot of words. What it also means is that you need to if you do anything like summarization or anything, you need to be able to support that context length. An alternative thing that you could do, use a large language model which spans such a large context length. I did that. I was able to successfully have it answer questions. I was able to create dynamically really good quizzes out of it, right? And I asked Bart to evaluate the quality of the lecture. Right? Can you guess what it said? Anyone? I suppose I'll show you guys what it said shortly. It was quite instructive. It made some very detailed feedback on the lecture, but basically it said very clear and so forth. But it's amazing that it could give such detail. And I asked it to specifically point out if I missed a topic or is there any area to go deeper into. And so now you can get all of those answers. We live in a world that is heavily AI centered. So once again, remember guys, we have taken a long journey. How many of you have felt that we have really covered a lot more territory than we imagined we would cover? Right? And yet, as most of you feel we have covered a lot of territory, that will become obvious. I must say that it happens to be less than half of what I thought I would cover. Right? So one of the things we need to think through is what do we do with the rest of the topics and how should we frame it out? A lot of, for example, fine tuning is yet to be done. Graph neural networks is yet to be done. A vital topic as anomaly and fraud detection, outliers, anomalies, and fraud detection. We haven't touched upon. Graphs are very important, of course. Things like AlphaFold, etc., come under that. Some crucial topics in reinforcement learning along with this is very much in context. We haven't covered that. And yet we have been moving, I hope you feel very fast, isn't it? So we need to, I would like to have some proposals of doing that. So one thing is that this is enough. We are tired. Right? The other, and so no more courses, no more boot camps, etc. This is the terminal one. The other alternative is we do go and cover all of those topics. Right? Now, just to give you a measure of how much I'm having to condense, document AI is a vast topic. It covers a breadth of history. You'll be surprised. When did document AI start? Like our ability to extract data from just a picture. When do you think it happened? Make a guess.
1 year ago.
1 year ago, huh? No, it goes back to, well, you'll find how far it goes back to. Right? Soon you'll find out. So once again, support vectors, we are Sherpas on your journey. I hope those of you who reach out to us and ask for help are getting the help. Is there anyone who's not getting enough help? If so, please do reach out to me directly. There are a lot of us willing to help you. This is obviously the mission of support vectors. We translate bleeding edge research and innovations into high impact products, right? Which by now you must feel that we do have expertise in. This bootcamp is all about this, going from theory to practice, theory to enterprise class products. It's very easy to write 5 lines of code, copy it off Hugging Face or some blog and say, oh, look, Ma, I did this, right? It's an entirely different thing to be able to build something practical and go to market with it. And you will realize as you guys are doing this, I hope you're realizing that you're facing issues of scale. You're facing issues of automation, right? Of management. By the way, one other important topic that I missed is feature store management. And I'll cover it at some point. But anyway, those are all like, it's a big world that we have to cover. And I keep saying this slide by now, you guys must be tired. I always start with this. The point is to drill it into your heads. I hope by now you know that AI is more than just ML models. Right? To build something of value is a giant ecosystem. It's true for everyone. For example, Chat GPT, the only thing that we know is the amount of infrastructure that has gone into it is far more than anyone imagines. That's obviously both Microsoft and OpenAI CEO, they keep pointing that out, which means we don't know what has gone into it, but it's a huge amount. But what is true of that is also true of any of your projects. By the time you're done with an AI project, you'll realize that a lot more goes into it than just a model or two. Right? You have to build the data infrastructure, the ML platform, the ML ops. You have to train the people. You need to gather a bunch of really bright people around you to get it done. You have to worry about the ethics and interpretability. AI is dangerous. You have to worry about the many things: monitoring, security, compliance, etc., etc., the data visualization, and it's a very iterative process. This is your MLOps stack. People are busy, data scientists and AI researchers are busy building models, better and better models. Data engineers are busy retrieving the latest data, creating accumulations of data and feature engineering. The ops people, the DevOps people are busy creating the entire pipeline, take it all to production. So it's a big journey that happens, and this journey has by now many steps. These steps, the main pipeline you are now aware of, it takes ingestion, cleaning, validation, transformation of the data. All of those are data stages, sometimes labeling of the data. These are very expensive steps. Quite often, it eats up 70 to 80% of the time. And you will realize that when I ask you to fine tune. Right? So guys, this part, when you are doing the teaching assistant, AI-driven teaching assistant, on all the videos, you'll realize that you can't do it without fine-tuning. A good teaching assistant will need enough fine-tuning. I want you guys to collaboratively discuss and figure out where exactly you need fine-tuning. That fine-tuning will require you to prepare a lot of label data, right? Which will, and I'll give you an idea. People who came and asked me, I said, sit down and create at least 2,000 instances of label data, a data set of at least 2,000 rows for each of the tasks. So obviously I'm leaving it as a hint because I know that most of you have not yet even started thinking about it. Right? So I won't give you out the solution, but you have to do all of that. Then comes the training stage. You will realize that you have to do a lot of experimentation to get the virtual assistant going. Right? And please do it well. Really, I'll request you to do it well. It's a very focused problem, creating the virtual teaching assistant. And think of it, if you do it well, it's a gift to the next cohorts, the next generation of people who come here. Because whoever does it best will make it official and use it. We'll host it on our portal and use it. So that's that. So there's deployment considerations. As you guys know, it takes a while to deploy these things, complicated infrastructure. So then you have to do monitoring. So what's our lesson plan for today? Today, as again, our format remains the same. We are doing some, oh, by the way, some administrative notes. Once again, teaching assistants are here. Logistics, food. Logistics, you guys are fairly good with keeping your rooms clean. So, but occasionally I find fast food remnants, do clean it up. Or if you use utensils, bring them back to the sink and rinse it. Otherwise, after a long day, I'm busy rinsing those dishes. So please help me out with that. Teaching assistants are available to help you. And now we walk through what we have done. Now, guys, take this audio part, the teaching assistant part, again, very seriously. You will learn the issues involved in multimodal learning. Like when you deal with audio, what are the qualities? It is not that easy to train a transformer model and get it to speak, to make an AI speak with my accent or my style of speaking.
So you want the teaching assistant to converse with you in voice, right? Not text.
In voice, yes, to be able to talk in voice. So imagine you have a voice interface. You ask it a question, it goes and finds the right information, generates a text. Now that text doesn't exist in my voice, but it has to synthesize and speak it out in a way that I would speak it out. It should capture my accent, my choice of words, my linguistic mannerisms, and come out. Is it possible? Anyone? Is it possible?
I think it's possible. It's dangerous.
Hmm?
Very dangerous.
Yes.
Everybody's scared.
Yeah.
Already you're getting calls, right? Somebody, I mean, virtual assistants are calling you nowadays.
Right.
It is scary. I don't know that my boss is answering for that.
Yeah.
You know how many divorces are going to happen? People think, right?
That's true. So guys, let me put it this way. I have the solution with me, right? But I'm not going to release any more solutions. I'll just release small snippets because I know that you guys are behind. And the basic rule is don't release a solution till everybody has tried. So at this rate, if you continue, you'll see the solution in January. Right? So please make a little bit more rapid progress. I know it's holiday season, but holidays can have their own blues. It's dark, cold winter nights. What better thing to do to cheer you up than to start writing code? All right, I'm joking. So we will do a lot of paper reading. Actually, today we'll do 6 papers. I'll cover some of it depending upon how much time permits. I will do guided paper reading of some, or maybe some you guys can do, right? Because it's a vast topic and I have condensed it into a single day. We'll do our team presentations. Is there any team that's willing to do a presentation of their work? So, please go ahead. Masmi?
Yeah, we might be able to do that today.
Okay, wonderful. So we'll take that. On the generative AI, guys, today surely the Cambrian Explosion series, surely we have something to share, right? The OpenAI has just had a new release. Many of you must be excited about a lot of things. A lot of breakthroughs are happening literally as we speak. How many contributors to the Cambrian Explosion? Anything new? Share something new.
There wasn't much interesting stuff this week.
Oh, there was, but you were busy. Okay. So in that case, we may use, because we have a lot of research papers to read, I may stretch this much further. We have a lot of papers to read. So
Hey, one request, Asif. Last session we wasted a lot of time. Can we stick to time today and under a little early in interest of Diwali? So let's not waste time today and stick to the schedule.
Sure, we can do that. We could do that. I suppose it is. It also means that I'll have to do. So guys, how would you prefer? Like, I'm ready to do all the paper readings. Would you prefer that, or would you rather that you guys contributed and stepped forward for paper readings?
Can you do the reading today and end early?
Can I do the paper readings and end early? 2 separate requests. End early we can do, irrespective of who does the paper readings. Anybody feels that you guys would prefer doing the paper readings? Any volunteers? No. Okay, I'll do the paper readings then. So let's go over the territory we have covered so far. I called it the journey of 1,000 miles, and it's beginning to feel like that, isn't it? Right. So we did text processing, we did vector databases. Would you agree? We have done these things, right? We did hybrid AI search. using that. We did multimodal search. We did, oh, memory is misspelled. Memory efficient fine-tuning, LoRa and so forth. LoRa. Come again? Forgotten. Forgotten, huh?
No, not yet there.
Okay, yeah. We did retrieval augmented generation, RAG and active RAG. We did diffusion models.
So you say, did we read the paper or did we do it? We read the paper, we didn't do it.
Diffusion models?
No, the memory efficient fine-tuning.
Memory efficient fine-tuning, we read the papers.
Yeah,
yes, that is true. You haven't done it.
Yeah, we've read a lot many more papers than what you
Then we have done, yeah. So you would need the LoRa thing, you would need for the virtual TA. The virtual teaching assistant will need you to do LoRa.
Really?
If you want to do it well, you can do without it. You need to do domain adaptation.
That's a hint. Right?
That's a hint.
Okay.
So think about it this way. It's a domain adaptation. We are talking of a very, very narrow domain, machine learning. Therefore, to get better answers, you need to fine tune.
I agree. That part I agree, but not for virtual assistant. Like the point is, you could be doing a text search after that. What you need the QLoRa or LoRa is to fine tune a broader, like a Mistral or something, on the limited content for that particular field. And that's where I got confused. Not for the virtual TA, because I thought virtual TA is what we did last week. Adaptation to your accent.
No, there are two aspects to it. One is the actual content that is produced by the teaching assistant. That will need LoRa, right? Because if you look at it, you already have actually approximately 35,000 tokens per video and 350 videos. Right? So you have millions of tokens, absolutely the right amount for fine-tuning. And then only will you be able to get answers much more precisely based on what is said. Right? Then the second,
why can't we use RAG for this? Why can't we use RAG for this?
It is RAG. I'm saying you need to fine-tune that.
But why do we have to fine-tune? We could do an index search. We already have the hybrid search. We can do an index search and then feed it.
Okay. Who would like to answer that question?
Inference.
Patrick.
So not just content, if you want to make it to sound like Asif and to get Asif's choice of words when he decides to format a reply, you want to get a lot of passages that Asif says, so that it becomes like a template of this is how Asif would probably answer the question, and this kind of sentence structure, this kind of choice of grammar and vocabulary. Pitch.
Yeah,
that's not
just the content. Just the text. So what Patrick said, in case you didn't hear, and he got it absolutely right. See, it is not just content, the semantic content. When you want to speak like a person, you have to capture the linguistic mannerisms and the diction, the language. Everybody has a unique speaking and writing style. And to sound more realistic, you need to capture that, the style, and that style capture, that part is where you would use LoRa. That is one part. The second, of course, is the voice part. The second part of the project that Satyam was referring to is the voice part of it. Of course, you need to train on the voice and speak that. That also you need to do. So yeah, that answers your question. Yes, Sachin, go ahead.
Yeah, Asif, the question was that, say, suppose you have these videos where the content is spread across different videos, right? And we ask a question that takes snippets from two different videos. It has to put together and make a cohesive, a concise, like, summary of those two snippets come together. Isn't that also required as part of the fine-tuning initially? Like the chain of thought processing or something like that. I may be saying it wrong.
Yes. So, Sachin, there's a lot that you can do. Depends upon how much you are willing to do. But what I'm saying is that use this as a good reason to use things like LoRa, QLoRa, etc. Right? Because that will get you into the game of fine tuning. There is a big inference server just waiting for you guys to get busy with it. Right? All of you have now, each team has an account on it. I know of only 2 teams that are using it currently. So I was going to quota it that every team will get only 1 day because I anticipated that all of you would be jumping all over it. But instead, at this moment, guys, it's tired. I mean, I overestimated how fast I can go. So you guys are a bit behind. But when you come around to it, you'll realize that fine tuning, there are many occasions or places to fine tune. And every time you fine tune, the performance or the how well your model does goes up significantly. Why? It's a very limited domain. What I have taught in the millions of tokens that I've produced, right? Actually, it's more than 10 million. 10 million tokens that I've produced. Is it big data? It's almost big data now, right? So it's all about one topic. It is a perfect use case for fine tuning. My language, I am told, is unique. Right? In fact, not just told. If you do a linguistic analysis and statistical analysis, you can literally see the fingerprint of my language, and I know that it is quite distinctive. People spot my language from a mile away. In the companies that I worked, people would always know that I wrote this document or this paragraph. So it is a perfect opportunity to fine tune. Yeah.
So I wanted to understand the difference between like a RAG versus a fine tune. Okay. Like Mosmi also brought this up, right? See, the thing is, whatever you have taught, let's say we transcribe it, we have the text for it or whatever, we use it in our RAG system. It will give us the content to answer the questions. So the fine tuning is actually needed to produce it in the form that Asif says. So it is for form.
The text of it, the dictionary.
Right? I mean,
that is one way to do it. That's one thing you need. But think about it this way. Even the vector embeddings that you do, right? Because you're talking of such a limited domain.
Right.
So what happens is, okay, think about this way. You have a model that sentence embedder that does sentence embedding, right? What it does is it will efficiently use the vector space. So what it means is all the world's knowledge, it has diffused across the entire vector space. Yeah. Now what happens? You bring a very domain specific data, machine learning lectures. You use that sentence embedder. What will it do? It will go and populate a tiny corner of that vector space, right?
And the model is also going to become smaller and all that.
No, so it is occupying a tiny. So
Hello, is it us or Asif?
It's Asif,
Yeah,
I
I
guess.
think we lost him.
Hey, Kate, are you trying to alert Asif?
I think there's a power outage or something.
So are we planning to go till the end of the day or like wrap up early today or any idea?
Think he didn't clarify towards the end what is he doing, but we did propose to end early.
Okay.
Hey, is anybody there in person who's also on Zoom?
Let's ask.
All absent people raise their hands.
Okay, he's rejoining.
Mausami?
Yes.
Mausami, you said you're presenting today, right? Is it going to be on Zoom or are you going to do it in class?
I think on Zoom.
On Zoom. Okay.
Yeah, we're not planning to be there. I'm a little pissed that we're having this class on Diwali, so I don't plan to be there.
Okay. Okay. Yeah.
But I thought like we had to do a good beginning on Diwali, right? So
There are other ways to do good beginning. Okay, let's not go there, Sachin. I'm
my
not in the mood.
wife is also not too happy, so I am with you. But she's like,
I talked to Asif last night about that, and he said he'll make it very short. Doesn't look like it's going to be short.
I have a lot of homework, Madhu. It's like I have to clean dishes, vessels, and all of that stuff.
There we go.
Yeah, a lot of festival chores and the class is like too much today.
Yeah,
and this is how we are doing the class. We might have as well given the day off, right? This is what I mean by wasting time.
yeah, I actually recommended he did the class and tomorrow, but he was,
Yeah, that was a good idea.
yeah. Well, Asif's daughter is home, so he's still doing the class. You can imagine that. Yeah, well, I think he'll keep it short. I'll talk.
All right, folks.
Do it.
I am back. I apologize. We had an internet issue in our in this place for reasons that I will understand soon.
Hey, Asif, in the absence of the emperor, there was a big rebellion.
Oh, what happened?
Revolution that happened. You didn't know about it.
Tell me.
Madhu will give you the news.
Dude, what's up?
So everyone was hoping that we could keep this class short today in lieu of the festival.
Oh, I on the other hand was hoping that we'll all do firecrackers in Diwali at support vectors itself. No, guys, I'll make it short. But
Thank you.
how about this? Document AI is a big topic. How about this? I do only half the topic today and we cover the rest next time. Is that fine? And yeah, let's do it like that. So guys, that is it. We have to do LoRa's and there'll be opportunities to do LoRa's. We did diffusion models. We integrated it into your project. The one thing that we haven't integrated into the project is adversarial attacks, but we did cover adversarial attacks. It is important to know that despite companies coming up and saying they'll protect you against adversarial attacks, most of those attempts or so-called safeguards are snake oil salesmanship, right? Because to my knowledge, nothing works.
If you look at the official solution for that, is exactly train it on adversarial data.
Oh my goodness.
So, and that is the official security solution.
Yeah. So Satyam is pointing out that the official security solution is to train it on adversarial instances. You cannot. There are infinitely many of them, and your model will become poor, and it's not going to help you anyway. Then we did voice cloning. We did a lot of audio stuff last time. And now, today, we are going to do document AI. So I must modify that by saying today and next week. So we are going to give 2 weeks to document AI. It's a big topic, right? But then, quo vadis. What is that? Anyone remembers what this means? Who goes there? Who goes there? Now try it out better. Very close. Quo vadis, where are you going? Actually, it's a biblical reference. Kate, you probably remember this one. Quo vadis. It's from the New Testament, I believe. Must be for the New. Okay, so where are we going? So the question is, where are we going? I would like to give a minute to discuss that. See, guys, we are moving very fast, but we are not covering all the territory. So one of the things that I would request you guys to discuss is come up with a format. And obviously, it doesn't mean that you're committing to registering for this course. You're just helping me in curriculum development. I will list out the topics that we haven't covered. You guys suggest what should be the format of covering those topics. You guys have made good stride. As you can imagine, we have covered a lot of topics. Yeah. Vast territory we have covered, and yet vast territories remain to be covered. Come up with the idea of how we should go about that in the future. So today's topic is document AI. Right? Again, a vast topic. So it is using AI to process documents. Documents usually mean this document. You see this document, guys. Yeah. You see that there's color here, there are footnotes here, there are things, there are figures. Right? I just randomly took, which one was it? Excuse me. This was the active RAG document sitting on my table. And by now you know that whenever I read a paper, I tend to do a whole lot of highlighting. So you see it. Yeah. So this is what it is about. So what is document AI? Document AI refers to the automated processing and understanding of documents using machine learning and natural language processing techniques. Big sentence, but that's what it is. Document AI allows computers to analyze, extract data from, and make sense of documents in an intelligent way. Anybody can tell that I don't typically write like this. So I was going to write and I felt lazy. And I asked, I think, Bard, define document AI. So it came up with this. Or was it ChatGPT? I forgot which one. I asked it, and this is what it came up with. I tend not to write such language.
Document AI is a terminology in the ML community.
Yeah. It's a formal term. It's a subfield. It's a big subfield.
This is new, this is probably very new, correct? Document AI.
Well, let's see. So here it is, the ancient history of document AI. 1966, in the world of vacuum tubes. Right? So if you think it is new, think again. Why? Because as computers came, one of the first questions people asked is, oh gosh, we have libraries full of books and offices filled with documents, government offices, bureaucracies. Do you guys remember the word red tape? It comes from actually folders that had red tape around them, which would contain your case. You apply for a loan, your loan application would be in a red binder, a red thing. And it used to literally have flaps. And you would cover it up and then tie it with the red tape.
So you remember the office thing that we used to write the next person's name and use the same folder, put it in the out thing, and it goes to the next.
That's
person.
right. Yeah, it would go to the next. So all of that world, mountains of paper documents are all sitting there. All we can say is people have used scanners to scan a large number of them. As you know, Google has scanned huge, vast libraries. Madhu put online, I think, a link to some 10 million documents or 10 million or million textbooks, and that you can use so long as you're willing to do good document AI, good text extraction from it, accurate text extraction from it. So that is the challenge. You guys can use that, right? This is it. So the first commercial OCRs were already coming and doing pretty well in 1992. Then came deep learning. And by the way, those were not bad. I mean, a lot of them used support vector machines and other things, and they were doing pretty good. Then came the deep learning, changed the game with CNNs and so forth, right? The RCNNs and CNNs, recurrent CNNs, etc. These were game changers. In their time, there were big revolutions. Right? In fact, the RCNN model is still in fairly widespread use. Then came, obviously, transformers, and then people began to ask, how can we use transformers? And then those transformers became this big, large, like some of them became large pre-trained models, because soon people realized that you can't train a transformer. You need a lot of compute power to train a transformer. So transfer learning became the norm. And so you started with pre-trained transformers. And the rest is history. Now, if you feel that this is one backwaters of AI, think again. This is one of the most active areas of research for a simple reason. Solves a very practical commercial problem. So remember, you guys are creating in your project, you have taken in text, you have taken in images, you have taken in audio, you have taken in video. What have you not taken in?
Unstructured.
Yes, unscanned documents, right? Or things written. For example, can you look at this image when I talk of coffee and I give you a picture of this cup? Can you bring up this in your search result? Right? Or so things like that. Or if I were to ask you, do you have AI that can read what's written on this? You realize that it is not very geometric. It's not rectangular. Or one of the fallacies that has been there in this world is just find bounding boxes, and from there, in each of the bounding box, then try to figure out what's there. Rectangular bounding box. It wouldn't work because the text is, first of all, it's at an angle and it is on a curved surface. Do you see how hard the problem is? Right. So it is a big area of work. Much has been done, but much still needs to be done. Let us just say that it's a work in progress.
No, ChatGPT Vision will do.
Chat GPT vision will do it. Try it out and see how well it does it. Yeah, go ahead.
Are these actual milestones in document AI?
Yes.
Because I noticed that the gaps are decreasing, like 30 years to 20 years.
Oh, yes, yes. I did not space it. I did not space it. I just uniformly spaced it. It is non-spaced.
Okay. But does this mean that we're reaching a point where it's exponentially already?
Yes. Most developments, most big things have happened after 2020. Right? In fact, the papers that we are going to cover are all 2019, 2020 onwards. Right? So
Asif, it's not working.
Hey, Asif, question.
Yes.
Going back to the timeline thing, would you think that the 2020 and with large language models, it was some sort of a reset and it's a new generation of OCR capabilities being built?
I would say, see, in AI, right, you don't use the word new generation. Yeah, new generation you can say. I wouldn't use the word reset because, I'll come to that, because of the no free lunch theorem. There will always be a class of problems somewhere, practical problems, that an old model will do much better at. I'll give you an example. Even today, there are many, many OCR situations where the RCNN does pretty good. An older model, it does pretty good, actually. Oh, sorry. Just bear with me. There is a problem with this. So guys, I seem to be having a whale of a problem with things. So I'll go to the PDF version, which I uploaded to the course portal. Or did I just lose internet all over again? No. Yeah, I'm there. So guys, I hope you're aware that all these lesson plans, videos, everything is uploaded to the course portal. Even I go there as I'm going there to get a handle on it. All the live session recordings are there. So today's one was lesson plan 2, document AI. Let me open that. Oh. Anyway, save downloads. Give me a moment, please. View. How do you go into the presentation mode? This is all very, no, I don't want that. Let me just open it with simple Acrobat. Open with Acrobat Reader. And yet, isn't there a view mode, page navigation, full screen mode? Okay. Let's go here. Oh. I have no idea what it is doing. Yes, it's Windows. It's the last time. Okay, I throw in the towel. I'm moving to Mac. Since I can't use Linux to write on, so for the teaching thing, I'll do that. All right, guys.
It's a good day, Asif. You can move.
Sachin, what
Today is a good day to make the move. So.
Okay, we'll do that. Diwali, yes, of course. Time to change direction, invest. Yeah, go ahead.
Yes, so I had a question regarding the previous timeline. Could you give a sense of the difference in capabilities that were brought in by, like, when, say, there were improvements made in 2010 versus 2020, right? Because I mean, if we think of OCRs, for example, I've used some, let's say, Expensify comes to mind, right? where they ask you to upload receipt to expense, right? And it'll read some numbers.
Right away.
So yeah, so could you give a sense of what was not possible then, like maybe a high level versus what could be done?
Very good. Things like, okay, when you use RCNN, right, or CNN based methods, which started coming from 2010 onwards, we now know that attention, for reasons that we don't quite fully understand, is a fundamental unit of neural networks, more fundamental than we thought. And so there was a missing crucial thing. Now, OCR even today is not a perfect field. It makes a lot of mistakes. But the amount of mistakes that it made before and the amount of mistakes that it makes now, there is a sea change. Things that we simply didn't think possible without transformers, before the world of transformers, are now possible.
We give like an example as to, for this a simple example of say reading a receipt, right?
Yeah.
What could not have, because on my end, whenever I would like upload a receipt, it would come back with, hey, this was like.
Yeah, that is right. So if you look at the quality of what it read with transformer-based models, it's very accurate. So, okay, let me put it this way. There are two aspects to this document. One is the document detection, detecting what is there in the image, that the bounding boxes, this is the text area and so forth. The second part is understanding what's in there in that box, right? And today, both of those aspects. So the first is sort of like segmentation. Segmentation we used to do using, again, CNNs. With the coming in of VIT, the visual transformers, that itself has become much better, right? The second part is the understanding part of it. Once again, the moment it comes to understanding, because of attention, like you're able to tell this in the context of what has the previous couple of characters, right? It has become much, much better. See, if you think of the CNN, right, it conjugates in a very local area. Whereas what does attention do? It will look across those patches, all of that text, to determine what word it possibly is. You see the difference, right? And it makes a huge difference. And you'll see that. That is exactly what our paper readings of today and next week are. As you go through the paper, they will talk about it, that this couldn't be done and now we can do this. The claim of each of this research paper will be that so far this couldn't be done, now we can do this.
Okay. So to, like maybe let me try to come up with an example. So let's say I have two receipts, right? A grocery receipt and let's say a bill from a restaurant I went to. Something from. When you say understanding that what is written in those scanned images, and when you talk about context, is it this context, like in what context this invoice was created, and is that the context you're talking about?
Everything. So, for example, given a page, a typical scientific document, right, has, let's say, look at this page. It has tables, it has text, right? Look at another, let me just go to another page. It has sort of a table box, it has a figure, it has paragraphs. To be able to take it apart and know each of the things that is there, extract the table as table, the figure as figure, and so on and so forth. We couldn't do that before.
And line it up as it appears
as it
in sequence in the document.
That is right, exactly. We couldn't do that. And that's where we are literally coming to. So just hold on with the slideshow. Image processing, so what are the things you need to do? There are things you should do even before you do it. Clean up the image, right? Denoise it, do things, and you will see what are the steps you need to do as pre-processing. It says image processing, but think of it as pre-processing. Don't just feed your image into it, which is what most people do. They shouldn't. There should be a pre-processing step that sharpens and clarifies the image. People used to think that you need to do OCR, one of the basic OCR, optical character recognition, and then you do layout analysis, entity extraction, that this is the address, this is the person's name, this is the so forth, and then some downstream tasks. Let's say you're classifying it. Is it an invoice, right? Or is it a tax form, right? Things like that. So this is an example of a pipeline. You could do that. But some things are important to do. Like, for example, binarization is a word. It's an odd word that is used to say that you want to convert it to black and white, because that for the text extraction purpose, it's much better. Right? Now, if you want to recognize the cat in the picture in the document, then perhaps not. Right? But binarization will help you, because you know that text is usually written in black, and even if it is not written in black, converting it to grayscale leads to better thing. De-skewing, this, you scan the image like this, just straighten it out. Right? So you see that these days, all these applications on the mobile, like Lens and other things, they do that, right? Document is like this, they'll straighten it out. Yeah. So that is de-skewing. And when you straighten it out, what happens is a lot of these things, they assume horizontal rectangles. They build horizontal rectangles, right?
As if in binarization. So if you have a black and white image of a cat, do you create a third channel? Or you just keep it still?
You just keep it still.
So you don't standardize the
channel? No. What you do is you take the image and the output is another image, which is binarized. That's it. And de-skewing is important because why? The bounding boxes that you make, a lot of them, they're just assumed vertically and horizontally aligned rectangles. So if your text is like this, it better turn, otherwise it won't do. In fact, that is one of the limitations. And I would like to cover one paper next time called Text Snake, which is actually a lovely paper, but not much recognized and not much talked about, but quite a bit used actually in practice. That deals with, suppose a text is written literally in a peculiar shape, right? Or for example, here, look at this. The text here, do you notice that it is both at a slant as well as it is curved, right? How would you extract this? For situations like this, it does pretty good. We'll touch. Noise removal, remove the speckles and artifacts. So for example, you could use a denoising autoencoder, right? Or remove coffee stains or infilling. Right? So there is this whole
okay. I will go. I'm going to leave. Wait, why did you see?
Which one did you Pradeep? Class, sir.
Okay. All right. So optical character recognition is the granddaddy of all document AI. A lot of people, when they think document AI, they think, oh, OCR. It isn't just OCR. In fact, one of the things that I want to, and that may surprise a lot of people who have been in this field also, that you can do document AI entirely without OCR. That's one of the more, like for example, we are talking about recent breakthroughs. That's one of the big breakthroughs, that you could actually forget about the character by character recognition and still understand the whole document and extract text from it, right? You don't need to go to the level of the character.
So OCR is to create another data set that is just the text.
Just the text from. And there are tons of OCR commercial software. Right? If you ever buy yourself a physical scanner, I'm sure it will have some basic OCR built in.
So it's not the training of a system that can recognize text. It's the actual generation of
the extraction of the text in the document. Yeah. So imagine that you give this page and it will just extract all the text out of it.
So you're saying as if that at this current age of technology, we don't even have to go to that step of creating that separate data set of the text. The text.
So allergy. So see, what has happened is people just assume that OCR is the first step. It's called document detection. Where are the bounding boxes? What is the text inside the bounding boxes? That used to be the traditional way. Very recently, to a great surprise, a whole set of transformer-based models have come that says, forget about that. We can get away without it. And it's a surprise. So we are in a transition phase. The OCR-based methods are still very much there and dominant. And not many people have woken up to the fact that they can actually do without it. That's a new thing. That's why, I mean, the whole point of this bootcamp is to bring you up to the latest. So this is it. So look at this. I wanted you to see the seriousness of this. Look at this page. Right. This page is a real page that is there. By the way, this is an example taken from Hugging Faces. So all credit to the Hugging Face website. I should have said Hugging Face somewhere. Look at this. What does it not have? It has tables. It has figure, isn't it? It has text. This is how scientific documents look. And if I remember right, Shivani used to be very concerned. How do I read tables from text and so forth? So, and I told her, wait and the answer will come. I don't know if she's in the audience. Shivani? No. Anil? Kashish? Anyone of you? No. Okay. So you can do that. And this should give you an idea of how tough it is to do document AI. You see that, right? It isn't just extracting plain text, OCR. There is a lot more happening here.
So for the first plot, it's actually, is it like interpreting that plot and describing, okay, the trends going down versus...
You can do that. Yes, you could do that. Yes, that's the whole point. It will recognize it as a figure, and then you can ask this question, what is this figure saying? Right? There's a lot happening here. There's a text. There's a table. To be able to extract the tabular data as it is. Right?
We're entering layout analysis as it.
Yeah.
We are the goal here now is just to create the segments in the document.
Yes, this is a layout.
Given a tag this section means
this is
particular part of the document.
That is it.
So like for table of contents generation.
Exactly. And in fact, almost all the state-of-the-art models that do this layouts are language models. Right? They're transformers. In fact, one second. In fact, one of the leading was literally called Layout LM, which is in V3, version 3 at this moment. Ravi.
Yeah, this is only for image document, you are saying, the OCR.
No, this is a layout detection example of what it could do.
So what format should it?
Yeah, yes, do it from PDF document.
Oh, yes, PDF. Of course, you're doing it from PDF. Right? Because a PDF is an image format. It's one of the recognized image formats.
Yeah, because we have that archive document. Right?
That is right.
Extracting images. So.
And I literally have a paper reading on how to convert archive documents into proper good text. Now, all of you used what did you use? Tika to convert or something, or PyMu PDF or something or the other to extract text. And did you notice that it was rather gibberish?
No, that is fine, but we left out all the tables and images.
Exactly, that's what I was pointing out. It misses out all of that. So the question is there a technology in which you don't miss out that?
Tesseract.
No, Tesseract won't do. Tesseract is actually one of the worst things you can pick. Actually, it is the most popular thing. But for a situation like this, scientific document like this, Tesseract is a disaster. And the reason Tika failed is because it used Tesseract.
It's only for text, it does. Text, not for image.
It does. Tika has integration with Tesseract. Right? So anyway, guys.
Also, Tesseract doesn't recognize handwriting, right? Like in most of the medical claim processing and invoice processing, this is one of the issues that almost every company faces, the limitations of OCR.
Yes. So
and they all resort to cloud solutions, and even Amazon Textract, it probably performs the best, but it still has a lot of short.
Oh, well, I wouldn't call it the best, but I'll let you guys benchmark it. That's one of the exercises. Try these things out. You'll realize that the state of the art has moved forward, Haripriya.
We're using Textcraft for handwriting doctors.
So, no, it is the most popular used. But let me give you a hint. There's a new kid on the block. Right? So hold that thought in your mind. We have to do, so what is it? What are the tasks that you do in document here? So simple layout. What are the paragraphs? Detect the paragraph. So in this, what are the paragraphs? Here is a paragraph, text. Can you break it up into paragraphs? Right? Then you have to do table detection. Table detection is yet a specialized task. Do you notice that you don't just say this is a table, but you have to tell what are the columns in the table, what are the spanning cells, right? Text cells and column headers and etc. It is more complicated than that. And to be able to do all of that is quite remarkable that we could do that. Right? Figure, this is straightforward. Detecting which part of it is figure.
Asif, going back to that earlier thing, this is where we initially started with 10K documents, which has a lot of tables.
Yeah.
And we were trying to see how we could improve on secinsights.ai, which actually doesn't do a great job with tables thus far. And 10K is all about tables.
Yeah. And hint, there's an internal project within support vectors where we looked at 10K filings and we started it out. Praveen actually did a lot of the early work on it. One of the things that I did is I took one of them, and because this question was asked by Shivani, can we extract tables out of it? You can, and you'll see, you will, not only can I, but now you will learn how you can. So
I also put in a link. Llama Index claims they have an unstructured.io, which seems to be doing a reasonable job. I haven't tried it out. I put a link on chat.
Yeah. So, all right, let's continue, guys. I'm almost done. So look at this. We have text versus non-text. Now, do you notice that? Look at the logo. Inside the logo is a text. To be able to tell that there is a text there, and everywhere there is a text. Now, do you notice that I'm doing it all with printed text? The moment you do handwriting, things begin to fall apart. So the state of the art today is not perfect with handwriting. It's a very, very imperfect thing at this moment. The other is reading order. In what order should I read? Left to right, top to bottom, what is the word, and things like that. Headers and footers. Like, for example, to know that this is not actually part of the text, it is just the header or a footer, right? So these are things. Then after that, you can do information extraction. You can take out the unstructured text. You can extract out the key entities, key relationships, semi-structured things like tables, forms, surveys, downstream applications. So many things you can do. After that, you can use it for document classification, all right? You can categorize using a classifier. You can classify using a predefined rule, things like that. So you could do all that. So anyway, I'll just give you a few open source projects. Remember, no cloud project. This is open source only. That does a very good job for the OCR part. Now, having said that, you can actually bypass OCR. Still, I'm mentioning the OCR projects, right? Tesseract, I believe, everybody not hiding under a rock knows about it, right? So we have all used Tesseract. If you remember in the NLP with Transformers course, we used it very early on in the second or third lab, we used Tesseract, right? So OpenCV is a computer vision thing we are all familiar with. Why would you need OpenCV? For no other reason than to just read your image and pass it on, right? Now, Hugging Face, I'll come to in a moment. MMOCR is very good. Oh, I forgot easy. Sorry, I forgot one big one. The easy OCR, I apologize, write it down. I'll update the slides. Easy OCR is another good one. Actually, easy OCR does a very good job of document detection, the bounding box. And Paddle OCR, for example, does a very good job of understanding what's in the bounding box. So you have a question now? Okay. Then MMOCR is another library that's PyTorch based that's trying to do a pretty good job and does a pretty good job. I tend to use, like using all of this, there are no perfect tools. But what I'm finding is that the Hugging Face document AI is perhaps the best in my experience. It's doing very good. Right?
We did all of these in Documentum years ago. Like we had a product line called Captiva. We did a whole bunch of OCRs because a lot of companies had forms. So you define a form and accordingly it would structure, the code would extract and put it in a content management system. So
yeah, nice. That is OCR exactly. So what Albert points out is that in Documentum, the company did it years ago. Right? True. And now they must be using some of the more recent.
We sold the company, and I think.
Yeah. Who got it? Who bought it?
Multiple times. EMC bought it, and then EMC sold it to OpenText.
OpenText, okay.
So Documentum was basically a document database. So if you can build a vector, a content management system.
Oh,
that would be the king. I feel seeing all this.
Yeah.
Because the challenge there was the searching for documents, right? How do you provide security? Say, in your case, if you do a semantic search against your documents, it will go against everything and show everything. So you want to control who sees what, and that would be another challenge.
Okay, nice. Yeah, that's right. The whole access control and everything, the enterprise aspects. Great. So guys, it is good that we are breaking it up into 2 sessions. How about this? Today, I keep it to only one of the papers. Paper reading, just one paper. Is that enough, guys? 1 or 2? And the rest we do the next time. But I have a request, guys. If you are here, go to Hugging Face and do that. And there are a couple of blogs and articles there. You're read the paper, but after that, do those exercises. Can I please request you to do that? It's a very easy one. You'll be all out of here by 2 o'clock or 2:30. Right? Is 3 o'clock good enough? Is that early enough, guys? If we just end today at 3, or would you want to end even earlier? 3 is good, right? Okay. So we can all be out of here by 3. We just have to be more time efficient. Let's do the first 2 papers and do the Hugging Face exercises. That's the scope for today.
Exercises in
Hugging Face is a document AI portal. And there's a blog called Accelerating Document AI. Hugging Face has written a blog. Read that blog. Very good blog. Should I bring that up, guys? Let me bring that up here.
These are so easy. No, just looking at it because the abstract says 2.1 or 2.2, so that's 2021, 2022.
Yes, that is that, yeah. So here we go, guys, the document AI. Now, this is it. I want you guys to read this article, Document AI, Accelerating Document AI. Right? It's a good introduction to this field. This image, as you can see, I took from here.
I shared the link to that blog, Asif, on Zoom chat.
Oh, thank you. Thank you. Right? And see, guys, the fact that you can do all of these things today. Right? So you were asking, Prashant, what couldn't be done before? You see that. Right? So if you go here, actually, I've given you a paper reading and all of these. These are all big models. Right? It was updated a year ago. Right? But still, they're very good. The one thing that you don't see here is the Nougat. I've added Nougat to your list. Nougat is important. And the other thing that I've added is So this is where you start reading. I'll explain each of these. Oh, where am I? The TR OCR is transformer-based OCR. Are we together? Right. Donut is no need for OCR at all. Right. A big thing. NOGAT is the one. Those of you, some of you started by reading computer science papers on archive. Which team was it? Initially started with some computer science archive papers. Patrick, you and yeah. So what you could have used, a better one, would have been NOGAT. Right? Meta. Yeah. The layout LM literally does that layout detection we talk about. This is LILT is a very good paper. Read it. And table transformers. I brought this in specifically because a lot of you ask, how do we extract table data from PDFs? Right? This is it. And these are, guys, it's a vast field. This is just a sampling of what we can do. Right? Now, there are a few classics that I want you guys to read. Well-read papers. Like, for example, if you go to this paper, let's go here. Real-time scene detection with differentiable binarization. You notice that it has a lot of citations, 404 research papers cited. That's a fairly healthy number. This paper is often quoted and talked about. Do that. Then the other one that is important is, so this is on the detection part, detecting where the text is. This is on the SVTR transformer. This is on the, where is it? SVTR. So seeing text recognition with a single visual model. This one is on the understanding side, right? Paper. Then there is this one paper that's not much looked at. It's almost forgotten, but it's very useful actually. I find this very useful. So might as well. Let's go back and see. This is, oh, where did I go? Copy. Okay, let me just see how. Yeah. Oh, sorry, snake. I'm not able to get there, so I'll just do snake, a text snake. Maybe the link I put was not archived. And a very good paper. If you look at this paper, I want to show you the image of what it can do. Oh, I hate this Adobe thing here. Okay. It will read text from an arbitrary shape. So how arbitrary shape? Let's look at it. And this is what I'm talking about. Look at this, guys, coffee. You notice that if you try to do a bounding box rectangle, this is how it will be. If you do it as a slant or any of the traditional approaches, it doesn't work. But there is a way to read it perfectly. Right? And this, like, you can have text written literally in the shape of a snake. Right? That's why it's called text snake, this algorithm. Now, when you look at these images, guys, you realize that these are really hard ones to get. And yet it gets it. Right. The core idea actually is based on two of the papers that we have already covered. One of them being UNet, and the other one being the pyramid of inferences, where it talks about it. Images. It takes a pyramid of images and does inferences on them. Somewhere it does mention that it's inferences. Okay. So these are the papers that I want you guys to do. Worth reading. Let's do it in two parts. And that's all for today, guys. So let's get started with the paper readings. Let's do at least two papers. The first two papers. Does that look reasonable? And we will start our paper reading a bit earlier. Let's say 1 or 1:30 and be done in 1 hour. Right? 1.5 hours. 1:30 we'll start and we finish by 3.
So, Asif, why did you not talk much about that layout LMV3.
It is there. We'll do it next time. Here it is, layout LMV3.
Okay, okay.
Right, here it is.
Also, one quick question.
Yes.
How does this document AI relate to name entity recognition and stuff like that, which we talked briefly in the NLP course?
See, NER is a part of this. When you get the text out of it, the next question you ask in the document AI pipeline is, what are the named entities in this document that I just said? But NER is a more low-level task. It's more granular task that is applicable broadly in many situations. Yeah, please. Yeah, Patrick, go ahead.
So I said that we want to do a really robust document AI analysis. How will you standardize the output of, let's say, one LLM to the other LLM?
Oh, there are these benchmarks.
Let's say we have one that's layout analysis, and then one that is table detection, and then content. But how do you?
Oh, you create a pipeline, use all of it.
So it runs one after the other.
That is right.
It's not output of all of these equals the sum total of all of these is one document.
No, you pipeline it. So in reality, when you do all of this, and that's the thing I was hoping you guys would do. So for example, this is the layout one. Who asked that layout? Are we going to do?
I asked.
Yeah. So in fact, the figure that Hugging Face quoted is literally the figure from this paper. This is the architecture.
So the reason why I asked was there's this competition, right? IKEDAR, I think, which does the document analysis and recognition, which has more of these competitions for form recognition, receipt recognition, and things like that. And I asked Bart to say what are the technologies that over the years have started to show prominence in those competitions. It started showing this layout LLM V2 and then V3 starting to show up. And Google and Microsoft are actually hands down beating Adobe in this area, which used to be the leader. So you see these models are outperforming Adobe's technology. So that's why I started reading about it as you were talking.
Okay.
So
that's what I said. These are the I wouldn't by any means claim that I'm up to the latest. So if you guys find even more recent, latest and greatest work, let's share. I will learn. Yeah, go ahead.
If I have to put on, say, a multimodal search that only focuses on, say, text and image in context with these, right? Are these the OCR these transformers more generic and therefore maybe poorly performing on determining the context? Can you help me put that?
No, you can specify which parts you care about. So once you have the layout of a document, right, you can say ignore the figures, ignore this, just give me the text. Remember that
place for both to be used.
Both to be used simultaneously. In fact, usually it used to be a two-phase approach. First would be the detection phase. What is there in the document? Second would be the understanding phase. Okay. So, all right, guys. So I'm going to stop the recording. Anybody has a question before I stop and we end today's session? This session here. We start again at 1:30, guys. 1.5 hours to read the two papers and have lunch. Oh, so start at 1. Okay, we'll start at 1.
Which papers are we reading, Asif?
Only the first two papers. The papers are Transformer, OCR, and Donuts.
So, Asif, I have a question.
Go ahead.
So the bounding box method, right? I've not read this paper yet. So some of the challenging OCR situations that companies faces, sometimes there is no key, okay, and the value is based on the position of the form. This is a very prevailing problem in the medical claim processing. So in that case, even if we extract value in order to determine, I mean there are like keyless checkboxes just lying in the middle of the paper, in the middle of the document. And the way we deal with this, like, we take the pixel coordinates, which is based on the bounding box of the key value pair form as a reference, and use that to extract the information, right? So if how can transformers help here?
Okay, help here. I have a considerable expertise in dealing with those medical forms and doing it right. I know what you're talking about. So there are multiple aspects that goes very well. Actually, you're right. Not many people know how to handle this situation. Right? You can do a templatized approach. You could do, and there are multiple approaches. But the bottom line is that you can actually do a pretty good job and achieve accuracies in the high 90s. We do that, but I do know that at this moment, I don't know if there are many opens. There are many commercial open source that specifically focuses on medical forms. I had to do it, so I did it.
That's good to know. So I'm eager to try this transformer.
Sure. But let me put it this way, that everything that I use, you guys are learning. We're doing the projects well.